Hi, I'm Aaron. I'm also known as Writing Thumb, and I'm making a game called Quiver. You should be seeing some gameplay on the screen right now. If you're not seeing some gameplay on the screen right now, I screwed something up terribly wrong. So what Quiver is a moderately fast-paced, top-down shooter roguelike taking inspiration from the design of games such as Quake, Teleglitch, and Nuclear Throne. So, throughout these development videos, I intend to show different techniques and different design and development thoughts that I have while making this game. Now for the first one, I'm probably going to be pretty simple. It's going to be a short video. I'm going to be talking about the line of sight and fog of war system that I have, which is taken directly from Teleglitch. Now this is a really cool visual effect where the black polygons around the walls are shuffling around based on the player's position, and I have implemented this in Godot 3.2, and it's a really cool effect. You should be seeing some video gameplay from Teleglitch and also from my game directly. Now, the way I implement this, I'll talk about implementation now. If you want to take a look at the project, I have a sample project in the description below for you to take a look at how I achieve this in Godot 3.2. So, how I achieve this in Godot 3.2. Firstly, I take a Node 2D, I add it to the group of walls, and then I give it a sprite as a child, I give it a texture, and then I add another child, a polygon 2D, I give it vectors, so these vectors are going to be where the shadow will cast from. Then I give a script to this Node 2D, and I give it a function called getPool, which is going to get a pool of these vectors. And that way I can get the proper global position and global rotation of all these vectors so they're properly accounted for. So it's not going to be improperly positioned in the world. Now I'll create another scene which has a Node 2D called lightcaster, and then I give this a empty array, and in each ready function we get all the members of the group of walls. We call that function getPool we created, and then in the draw function we loop over all the vectors in our array of vector object. And then we take each of these vectors, we minus the origin point of our lightcaster and normalize it. Normalization giving you a vector with a scalar value of 1, which basically means you only have the direction. And then I multiply it by a constant, which is a very large constant, so it will be guaranteed to be a vector far out of the vision. And this way we can extrapolate how far the fog of war is cached to from each of these vector points. We then perform the convex hull algorithm, which gives us a set of vectors which are going to be in clockwise orientation, and that way we can then draw a colored polygon depending on how we want to, depending on this set of vectors that we now have. So in order to make the polygon shuffle around the player position, all we need to do is make one simple adjustment, and that is we're taking the origin point of the vectors. All we have to do is just minus a offset for this. So to do that, I just take the actual position of it. I take the position of the player, I get a normalized vector, like before when we were doing the extrapolation to get the shadow casted bar vector position. And then with this normalized vector, we can multiply it by an offset and then just subtract that from the actual vector. And that way we have a vector which is slightly offset. This way you can actually see some of that asset of the wall. If you didn't catch that wall, don't worry, I have a project link in the description so you can take a look at that. It's a fair bit of vector mathematics, and it takes advantage of some structure that Godot provides, mainly the pool of vectors, and it also combines an algorithm which a lot of people aren't familiar with, which is the convex hull algorithm. It's quite a cool effect, really awesome. Now there are other ways that this could be achieved, and there are some reasons why I did not achieve them in that specific way. The first will be Light 2D. Godot has a Light 2D implementation, which I had a lot of trouble with, mainly because the masking and the mixing had a lot of undesirable effects, such as not properly being seen outside the player's view. If that's the right way to say it, it's hard to describe. It doesn't get you a nice implementation. It's not easy. It's not easy to work with. It's certainly not that I can program with regularly. Light 2D isn't bad on its own. It's just hard to use in combination with other effects. Anyway, another point about why I didn't use it is that Light 2D. I'm not going to include any reference here. You can probably look it up in Google or whatever search engine you use, and you'll find that Light 2D is not at all optimized well for performance. So if you have one Light 2D, it will be fine. If you have a couple Light 2Ds, it'll probably be fine. But if you have many Light 2Ds, it's not going to be fine at all. And also on this point, the HTML export for it is not well optimized to use Light 2D, which is another reason why you might not want to use a lot of Light 2D. There's also another effect with the discrete tile-based fog of war effects that is usually done in some roguelike games such as NetHack. Now you can normally implement this much more easily than a raycast based solution or a polygon based solution as I've done here. but I haven't done that for this game, and that's for a pretty obvious reason, which is that it's not a simple, discrete, tile-based system. It's not a tile-based world, it's a much more complicated world. It's not tiles, but you can probably find more information on those tile-based algorithms and more tile-based fog of war systems on Rogue Basin. Anyway, I hope you enjoyed this video. It's the first development video of my game called Quiver. If you want to take a look at it, feel free to take a look. I have a website where I have blog posts, detail more information. I also have change logs for the game. And also you can get the executables, or you can play the HTML version of it. I also have an itch.io page for this game, if you want to check that out. I think that's all the information I need to mention. Oh yes, I have another information. If you go to the website page, you'll find a section for a mail list. If you want to enter that mail list, feel free to. Don't forget to subscribe, like, comment, all this extra stuff that burns my soul inside out deep at night that YouTube demands all its creators to do. Anyway, yes, okay. I hope you enjoyed. That's all. Bye.